Hello everyone, welcome back to the chess tutorial series. In this video, we'll be creating some of the background logic for our pathfinding. Let's go ahead and get started. So first, we're going to create a new enumeration, and this one is going to be for direction. So let's go under Blueprints, Enumeration, and let's just name this Direction Enum. Direction Enum is going to include a couple of different things. So first thing, we're going to need 1, 2, 3, 4, 5, 6, 7, 8 values. We're going to get left, and then right, forward, forward left, forward right, and then we're going to do backward, backwards left, and backwards right. We can go ahead and save that now. The next thing that we're going to do is we're actually going to be creating a blueprint function library. And what the function library allows us to do is to call functions from anywhere in the project. So that's why we're creating this on a function library rather than the board or a chess piece, so we can use it on both. So let's go ahead and create a function library. It's under Blueprints, and then Blueprint Function Library. We can just name this Chess Function Library. So let's go ahead and open up our chess function library. So this is going to be a little tedious. We're going to create about 9 different functions, but this will help us out immensely in the future of the project. So let's go ahead and create the first one. Name this Get Position Letter. And what Get Position Letter is going to do is we're just going to input a position. So we need a string. Name this position. And then left chop. Set the count to 1. Create a new output, and then we can hook this up. Let's name our output. We can go ahead and save, compile, and then position number is going to be basically the same thing. So get position number, except instead of a left chop, we're going to do a right chop, count 1, and plug that in. We can save and compile now. Next one we're going to do is called combined string array. And what this will do is allow us to combine 2 sets of strings. So let's just plug that in, create a new one. Combine string array. Combined string array is going to take 2 string arrays. String array 1 and string array 2. And the first one we are going to set to a local variable. Okay. And then string an array. And then the first array we're going to set to our string array. And then combined array, another value. Actually, we're going to set our string array. We'll name this string array 2. And then we're going to set string array 1 to combined string array. And then we are going to grab string array 2 for each loop. Then we're going to grab our combined array, add to it, and that will give us a combined array of string array 1 and 2. We can just return that super easy. So combined array. Plug that into our completed. And there we go. We can save and compile that now. So third function down, the next one that we need is we need get number from letter. And basically what that's going to do is get a number from A through H that we can use to pathfind. So let's go ahead and create a new function. Get number from letter. And what this is going to do is we're just going to take a letter input, and then from letter, just going to upper. Then we're going to create a local variable. We'll name this letters. So type in letters. And then we are going to actually add 1, 2, 3, 4, 5, 6, 7, 8. First one's going to be A, B, C, D, E, F, G, and H. Okay. And then contains, sorry, we're going to get a find. And we're going to add 1 to it. And then we will print this, or sorry, we will convert this to a string and then return it. Okay, so we can go ahead and save and compile that now. We are done with that one. The next thing that we're going to do is we are going to get letter from number. So we can just go ahead and copy this, get letter from number. Okay. And what get letter from number is going to do, we are going to take a number input. And then we are going to int subtract 1. And then we're going to check and see if this is less than 0. If it is less than 0, we're going to return nothing. And then also, if this value is greater than 7, we're going to return nothing. Okay. So if not, we're going to get letters, and then get, and then the index that we're going to use is this right here. Except we are going to clamp it. So let's type in clamp. We're going to clamp it between 0 and 7. And we can go ahead and save. And on false right here, we want to return the letter that we got. We can save and compile that now. All right, everyone. So we have gone through about half of the functions that we need to create. So let's just go ahead and categorize these really quick. So the next thing that we're going to be creating is get position in direction. So what this does is basically gets a position in the direction. It's pretty self-explanatory. And to do that, go ahead and create a new function. Get position in direction. We're going to create 3 different inputs. First one is going to be an integer. Second one is a piece parent object reference. And the last one is a direction enum. Okay, we can name the last one direction, this one piece, and this one length. Okay. So we can save and compile there. And now what we're going to do is a bunch of complicated logic. So try to follow through, make it a little confusing at times, but if you need to, just go ahead and stop the video and look it over. So we're going to check to see if the piece is valid before we do anything else. And then after that, we're going to create a new variable. Name this length var. let's create it in a local variable. So length variable. Make it an integer, regular integer. We're going to set this. Go ahead and do select. So for our index, we are going to get our piece, get team, and then plug it in. So if we are on the black team, we just want to, actually, if we're on the white team, we're just going to take the length. On the black team, we are going to multiply the length times -1. Okay. So let's go ahead and reroute this out here and over, because we're going to need that in a bit. And then let's go ahead and plug this in. So the next thing that we're going to do is we are going to calculate the letter that we need for the next direction. And to do that, we are going to get position. We're going to get position letter, get number from letter. Let's go ahead and make sure that these are pure, by the way. Let's go through all of them. Okay, so get position letter. And then we're going to get number from letter. And then toInt. And from here, we actually want to find our direction. Reroute this over. And then we are going to create a select node. So let's do select. And then let's plug in. Let's actually just do a select off of our direction. As you can tell, we have a lot of variables to fill here. That's fine. This is why it's going to get a little complicated. So what we're going to do is we're going to plug this value into our left, our right, and then we are also going to add and then subtract. Okay. So for adding, we're going to hook this up to forward, forward left, and forward right. For subtracting, it'll be backwards, backwards left, and backwards right. And then the variable that we're going to be adding is our length variable. We can just plug that in right there. Okay, so now we need to back to a string for this one. We can get letter from number. And then this will be the letter that we need from our get position and direction. Okay, so now what we're going to do is we're going to create the number logic. So let's just grab this position, get position number. Okay, we're going to use another one of these selects here. So let's go ahead and plug in the direction. Okay, and then toInt. And we're going to grab a subtract value and an add value. Hook those both up. Get our length variable. And we can hook this up to both of these. Okay, so now for the number, on addition, we are going to go into left, forward left, and backwards left. For the subtraction, we're going to go into right, forward right, and backwards right. And then just straight out of here, we're going to do forward and backward. And then over here, we're going to append. And we can just plug in this value right here. And that's it. So now we just need a return node. So we can just reroute this. And then create a new return. and the value is just going to be a position. We can close or remove the direction here and just make the output position. Okay. Now we can go ahead and save and compile. We are done with that one. We are going to move on to the next piece, which is get edge length, which is basically just going to get the length of how many chess blocks you are away from the edge. So if a piece was right here and we calculated the direction right, edge length would return 3. If you did left, it would return 4. So create a new function, get edge length. Okay, and this is going to be another kind of complicated one. So let's just go ahead and take it slow. 2 inputs, piece parent, object reference, and a direction. We can go ahead and keep that second one. Okay, so from piece, we're going to get position. And then we can get number from letter to int. And then we're going to get position number. And we're going to do the same thing over here. One more thing we actually want to do, we want to get position letter. So hook that up first, and then hook that up. Okay. So now what we're going to do is we are going to create a select function. So let's just go ahead and grab our team. So get team. Then we can select. We're actually going to need 4 of these. Hook these all up. Okay, and then we need a subtract. 2 of them actually. So we need an 8 minus this value, and this value minus 1. That's going to go into the white up here. And then the minus 1 value is going to go into the black. And then the minus 1 value will also go into the white right here. And the 8 minus will go into the black right here. We're just going to copy paste this, flip them around, plug in these values, and then from here, this one is going into the white right here, and the black down here. And this one's going into the black here and the white here. Okay, so now that we have those set up, we are going to use a select function here. Okay, and now what we're going to do is we're going to drag off of forward left, select, and then we are going to check if this is greater than or equal to this value up here. And this value will be going down here, and this value will be going up here. And we're going to do this again. We're going to plug in the true, this one, and the false down to this one right here. And we're going to check and see if this is greater than or equal to this. And if so, we're going to plug this into the forward right. This one's going to go into the backward left. And greater than or equal to, this one's going to the third one right here. And this one is going to this one right here. If true, going to this. If false, we're going to this top one right here. Or sorry, this second to top one. And we have one more of these to do. This one's going into the backwards right. And our A is going to be this one right here, so our true. Well, then false is going to be the third one, or the second one. Now we can go ahead and hook up backwards to our second one. Forward is going to go to the one on the top. Right is going to go to the third one. And then left is going to go to this one right here. We can go ahead and save. And we just need to create a return. And that's going to be our return. We can save and compile now. That was a little bit daunting. We have 2 more to finish, so we're just going to go ahead and keep going. So the second to last one we're going to do is find path in direction. So find path in direction. And what this is going to do is just find all the positions along a path. So we just need to get all actors of class. And then we want the chessboard. Just going to get a reference. Create a new local variable. Board reference. There we go. Save. And we can plug that in. Okay, now we're going to get edge length. Make sure this is pure. Make sure that we have 2 inputs here, piece and direction. Okay. Actually, we can go ahead and get rid of this actors of class. We can just get the board reference from our piece. Okay. Now we can plug that in, plug this in, and then we're going to do a for loop with break. First index will be 1. Last index will be this length right here. Okay, and then we are going to reroute this, make it a little bit cleaner. Okay, and then from here we're going to get position and direction. The length will be the index, piece will be piece, direction will be direction. And then this position, we are going to create a new local variable, call this positions, get a string array, and we're going to add to it. Okay. And then we are going to get our board reference, get position. Like we don't have that just yet. So we're actually going to go and we're going to stop on this find path and direction really quick. We're going to jump over into our chessboard. We have to we have to create a function for it. So the function that we're creating is called get position info. Okay. So what get position info is going to do is it's basically just going to check all pieces for any information. So get position info. We're going to grab all pieces. We'll get a position input. String position. Going to find. Okay. And then if found. So if found, we're going to check and see if this is valid. And then if it's valid, we're going to return. So our return needs a couple different things. Let's just go ahead and create one. There we go. So we're going to get piece parent reference. We're going to get a Boolean and a team enum. Okay. And then you can just rename these like I did. Okay. And if no piece was found, we can just go ahead and return not piece found or piece not found, and then save and compile. Let's go ahead and jump back into our chess function library. And then what we are going to do is finish up this function. And all we need to do is get position info. We can actually make this a pure function. So make sure that's pure. And then the position that we're looking for is this one. And if a piece was found at all true, then we are going to break. Okay. So last thing that we need to do is we need to get a return node. So let's create a new output. Drag this down here. And then what we're going to be returning is our array of positions. Okay. Now we can just save and compile. We are done with that function. The last function that we need to create is called clean positions array. And basically what that's going to do is just take out any strings in our position array that don't match up with the A or with the letter and the number format. So let's go ahead and create a new function, clean position array, input a string array, create a new variable, call this temp. Okay, then we can set this here. And then we're just going to for each and we're just going to replace any spaces with nothing. And then we're going to check the length. And if the length is not equal to 2, then we're going to go ahead and remove it from the string array. So we can go ahead and remove. There we go. And then on completed, we are going to return the temp array that we just edited. Make sure that's a pure function, as well as find path and direction. Okay, so we can just throw this into our string handling. We can create a new category called Pathfinding for this one. Do the same thing with this. Same thing with this. Now let's go ahead and close out of our chess function library, and we're going to jump into our piece parent. So let's open this up, and we're just going to lay the foundation for pathfinding. So we're going to create a new function called get all possible moves. And then we're also going to create one called set all possible moves, as well as refresh. Okay, so get all possible moves is going to take an output of, let's see, 2 string arrays. So movements and attacks. Just make it a string array. And then let's go ahead and create a local variable. Let's name this local array. Let's make it a string array. Save, compile. And then set possible moves, we're just going to get all possible moves. Let's just create a new variable here. Current movements. Okay. And then current attacks. So set all possible moves is going to set current movements and current attacks. Just drag those there, plug this in. Okay, save, compile, and then let's go over to refresh. And what refresh is going to do is get all and then set all. And get all can actually be a pure function. We can just hook that up right there. Save, compile, and the next thing that we're going to do is we're just going to create a new function, and this one is called find valid path. So let's just create it. Find valid path. So we're going to get a variable called length, a variable called direction. Length is going to be an integer. Direction will be a direction enum. Both of these just need to be single variables. Okay, so now what we're going to do is we are going to clamp our length between 0 and max. So go ahead and get self, and then get edge length in direction. We can plug that in for a max. And then as long as this is greater than 0, we're going to go ahead and find a path. Okay. So off of true here, we're just going to for loop with break. First index will be 1. First index will be 1. The last index will be our clamped value. Okay, and then we are going to get position in direction. Piece is going to be our input piece. Self, rather. So we can just grab this value, plug it there. Direction will be direction. And then after that, we are going to grab our board reference, get position info, plug in our position, and then if there is a piece found, okay, we're going to check and see if it's on the same team. Okay. And we're actually going to create a new array. So let's just name this local array. We can get that right here. I'm going to go ahead and add. We'll do another one right below it. Okay, so on true, we are going to reroute and then break. So if another piece was found and it's on the same team, we don't want to add the position. So equal to, and then on false, we are going to add our position. Okay. We can actually plug that in right there too. And then on here, so if there wasn't a piece found, we are just going to add and then keep going. We actually want to break on this one too, so let's plug that in. Okay. And then on completed, we are basically just going to return the local array. So let's put that right there. Grab our local array, plug that in, and then also off of this false, we're going to plug that in right there. Okay, we can go ahead and save and compile that now because we are finished. So the last thing that we are going to do is we are going to jump into our chessboard and we are going to create a new function called update moves. So let's click update moves. And then for the input, we're going to take an array of piece parent object references. We're going to for each, and for each, we're just going to refresh. That's it. So let's name this array, and then let's just make sure to call this on begin play. So there we go. And then for getting this value, we need to grab our pieces right here, and then we can get values and plug that in right there. Now we can go ahead and save, compile, because we are finished. That's it for this video. I hope you learned something. In the next video, we'll be setting up our pawn's pathfinding and getting our movement functionality put together. Thanks for watching. See you next time.